So welcome to today's lesson on radiation. So by the end of a lesson, you should understand that ionizing radiation can be detected by photographic film or GeigerMuller detectors, explain the sources of background radiation, and understand that the activity of a radioactive source decreases over a period of time and is measured in becquerels. Right, so how do we detect radiation? There are two ways you can detect it, either through a Geiger counter, which you've probably seen in movies, which ping off once ionizing radiation passes through it, or through a radioactive badge, which goes black if there is ionizing radiation about. Okay, so radiation badges are essentially photographic film which turn black in exposure to radiation or light. But because light cannot penetrate the badge, ionizing radiation can. So it means if the badge begins to darken, it means there is ionizing radiation about, so you need to get out of there. In terms of the GeigerMuller tube, so as we know, radiation produces ionizing radiation, or radioactive ores and radioactive material produce ionizing radiation. And if it passes through a low pressure gas, it's going to produce ions. And if you set a positively charged and a negatively charged tube, that means that the ions are going to move, okay, because they're charged. So a pulse of current or a negative charge flows that is registered in the counter if the current is moving, okay, because remember current is just charge moving. There is a thin micro window which allows alpha radiation to get through, okay, because remember, because it's so slow moving, it gets stopped by even just a few pieces of paper, and gamma radiation and most beta radiation can actually enter through the sides of the GeigerMuller tube. So in terms of activity is essentially equal to the number of radioactive decays per second, and it's measured in the units of becquerel or BQ, named after Henri Becquerel, who discovered radioactivity in 1896. So 1 becquerel equals 1 decay per second. So in terms of background radiation, basically background radiation is a low-level ionizing radiation that is produced all the time on planet Earth. Now, most of the radiation occurs naturally, but a small amount in recent years, since 1950 roughly, has been due to such man-made sources as nuclear weapon testing in the Pacific. Radon gas is also a source of background radiation. It's about 50% of the natural background radiation here on Earth. And what happens is that two isotopes of radon, radon-222 and 220, which are produced by the nuclear decay of uranium and thorium in the Earth's crust. This is a gas, or radon is a gas, which therefore seeps out into the atmosphere. So areas containing igneous rock and cave systems have higher than average amounts of background radiation due to this radon gas. And we can see here in Cornwall, in the map here, that has higher levels of radon gas because there's lots of limestone caves which trap the gas in Cornwall. So another source of radiation is cosmic rays. Again, they're a form of natural background radiation, and they're produced again by nuclear reactions involving stars, this time out in space, involving supernovae. Actually, those are the exploding stars. They produce high energy particles which bombard the Earth's atmosphere, but luckily our atmosphere is quite good at protecting us from this cosmic radiation. But it does mean that if we are flying an aircraft, we get more cosmic rays because we don't have that protection from the atmosphere. Then we have internal radiation. Okay, it's basically caused by radioactive sources present inside our actual bodies. Okay, so for example, carbon-14 is formed in the atmosphere by the sun's radiation, and we breathe it in or eat it in terms of food. Okay, because sucrose, for example, because plants obviously create it through photosynthesis, and we also exhale it with radioactive carbon dioxide. Other forms are strontium-90, which are formed by nuclear weapons testing again, and basically what happens is strontium actually replaces the calcium in our bones. And also we get it from food again, so there's a banana, we get radioactive potassium from bananas as another example. So in terms of artificial radiation is produced by man-made events like, for example, nuclear energy disasters like Chernobyl or Fukushima, or nuclear weapon testing. And radioactive traces are also used in medicine and industry to treat cancer and find leaks, for example. So these are all forms of artificial radiation. But these are really only a small percentage of what makes up the background radiation. Okay, and we can summarize that in this following pie chart. So most of the background radiation is in the air, probably in radon gas. We have cosmic radiation causing 13%. Food and drink, remember those radioactive bananas, 15.6% of background radiation. Ground, about 16%. Medical, 21%. Nuclear weapons, only about 0.4%. And air travel, due to those cosmic rays, about 0.3%. And finally, nuclear reactors like Chernobyl and Fukushima, about 0.1%.